Hey guys, welcome back to another video about the CBC solver. Recently I was asked, how do you compile a parallel version of the CBC solver? The CBC solver itself is capable of doing calculations in parallel, and there is an instruction on the GitHub page how to do this. And basically all you have to do is to link a pthreads library against your version of CBC. So pthreads is original for Linux, but there is a Windows version available, and in the following I will show you how to do this. I will stick in a similar situation as I was in my first video about CBC, meaning that we are working on a 64-bit system, but however we want our CBC to work only with 32 bits. We do not follow exactly the instructions, because if you look against the pthreads Win32, which is linked here, you see the release is rather old. It's from 2012. You can do this, you can download this, and you can link against this. This works perfectly fine. But however, I want to show you another way. Because on GitHub, there is another way, there's another nice project from GerHobbelt, which is called pthread Win32. And we want to use this pthread version for our CBC solver. And of course, there's a reason why we use this project, because this guy has made the effort to provide the Visual Studio files to compile this pthread version for different settings. So the first step is, well, download the repository. First we create a new folder, or we just clone the repository here. I use Tortoise Git, but feel free to use whatever Git version you want to do so. And there you go. Let's clone the repository. There it is. Super nice. Let's have a look inside. There it is. You can see there are some CMake files and some C files and stuff like that. There's a pthread.h file, which will be important later on. But most important, there's a folder called Windows. And in this Windows folder, you will find the Visual Studio solutions for different versions of Visual Studio. Let's take the newest one, which is from 2019. Open it, and there you'll find the pthread 2019 solution. So let's open it. Take a couple of seconds. So now, because I'm using a newer version of Visual Studio, it asks me to upgrade it to the latest Windows SDK, but I do not want it. I want to build it with the 2019 version. So again, we want to build, for the sake of purpose, we want to build a release version for 32-bit system. So let's change the debug profile, the profile here at the correct architecture. Well, all you have to do now is right-click on a solution and build it. So this might take some while, so let's fast forward. Works perfectly fine. So if you are active on GitHub, give this guy some props, because this is good work. I like it. So where is the library and the stuff we need? This is now put into the bin folder, and there we'll see our 32-bit version. And you will see there is a pthread.dll and a pthread.library. We will now need, for now, we will only need the library. So let's go to, before we link CoinOR or CBC solver against pthread, let's have a look at the CBC solver itself. If you are unfamiliar what this here is, I recommend you to watch our first part. It will be linked in the description of this video. So the speciality about this is we have a debug profile. We have a profile for a parallel version for the CBC solver already available. This is located in the CBC file. Then go to our Visual Studio files, lose the latest version, and open the solution here. There you go. We want to build a release version or a release parallel version, which you can find here for 32-bit architecture. And all they have to do now is to link pthreads against CBC. But first, let's have a look at the speciality of this profile. What is so special about this profile? Let's have a look at the configuration manager. Here you can see the active solution. We've chosen release parallel for 32-bit system. And you can see only CBC, library CBC and library CBC solver have a release parallel version available. The other one, they are actually not needed to do in parallel. They mostly have some utilities, some interfaces and stuff like that. So they are now built with the standard release version. And what are the big differences? Well, for the sake of purposes, let's click at the release version. There you can see everything is built in release, and for debug, everything is built in debug mode. But we are sticking to release parallel mode. So let's open the properties of the CBC project. They will find something interesting, because if you go to C++ and then go to the preprocessor definitions, you will find the, let's make it a little more bigger, you will find the preprocessor definition CBC_thread. And this preprocessor definition is the reason that we are now linking, or that we are now including pthread.h, or at least it wants to include ph, but we still have to tell the linker where to find those pthreads files. This CBC thread is only available if you choose the release parallel version. This is the main difference, because this is how you control your code inside of the CBC version. Okay, now let's come to the most interesting part, and I will show you how to include pthreads into CBC. Let's navigate to our CBC folder, or to our coin_or folder, and create a new folder which we call pthread. Inside this pthread folder, we create two additional folders which we call include. This will of course contain our header files which we want to include to the C++ file, and of course we need the library which we just compiled. So let's start with the library. So go to our pthreads window. Where have we compiled it? We have compiled it in the Windows Visual Studio 2019 folder, bin to 32 bits, and there you'll find the pthread.lib. Copy it, plug it into our coin_or pthread lib folder. There you go. Let's do the same for the header files. Therefore, we have to go to the code, which is located inside the pthread win32 folder. There are a lot of header files. We do not need all of them. So let's go quickly through it. We only need, okay, you have to know this, we only need shed.h, pthread.h, and where is it? ptw32h. These are all the header files you need. So copy them and plug them into your include folder. Now we need to tell Visual Studio how to find them. Let's go to Visual Studio. As we just saw, we only need to modify the first three projects. So let's start with the CBC solver, go to properties, and we start with C++ in the general folder. There you can see there is already an additional include directory which is linked to pthreads. Well, we don't need this because we're using a different version of pthreads, so delete it. But what we want to do, we want to go to the include folder which we just created. So this is in the same folder as coin utils, so let's link it here. So this was pthread/include/semicolon. So this is all they have to do here. For this profile, there's a speciality. There is a vc vc++ directory, which is linked to the pthreads w32, which I just saw you in the very beginning, which you can find on the GitHub page of the CBC file. We don't need this. We use our own compiled version, so delete it. Perfect. So now we are done with the VCC directories. We are done with the C++. We have to tell the linker, though, where to find our library. So let's go to linker, general. There you have the additional libraries directory. Put our folder where we put our library. So this was a pthread/lib. And still we have to tell them to include pthread.lib. How was it called exactly? Just pthread.lib. Perfect. So just write it here, pthread.lib semicolon, and press apply. So now we are done with the, or we are nearly done with the profile. I forgot something, because since we have different property or different profiles for our projects, but they all are dependent. You can see them here, by the way. If you go to project and where is it? Project dependencies. You can actually see which project depends on which and actually how is the build order, and you can modify them. And you will see that CBC depends, for instance, on libcgl. However, libcgl is will be compiled in the release version, but we still need a library. So we run into some issues. So we have to add in the linker in general, we have to add /release. I'll show you in a second why this makes sense. Let's go to our CBC file, Visual Studio 16. If we now start to compile with the release parallel version, a folder will be created. This will be called release parallel. And there the projects CBC, libcbc, and libcbc solver will be put into. However, we will start with the projects we are dependent on. However, they will be compiled with the release version. So there will be a new folder called release. But our CBC exe will be put in this file here, but we are linking to this folder. So we have to go a folder up and into the release order, a release folder. So that's why I put here www release/ and semicolon. We can delete this for now. If you don't believe me, the folders will be created in a second. Let's go to the next. Did I just press apply? I'm not sure. I pressed apply, perfect. Let's go to libcbc. Same situation. There is this old version of pthreads here. We don't need this. Delete it, go to C++, add, so that we can find our header files, add the include directory, and that's all they have to do here, because we do not have to link anything here. Press apply, go to libcbc solver and repeat the same situation, repeat the same thing we just did. Delete the old stuff, add the new stuff. So let's try to compile CBC in a parallel version linked against our pthreads version. I will kick out those unit tests because actually we don't need them, so screw them. And let's try to compile CBC. This will take again some time. I will put it into fast forward mode. So it looks good to me, and by the way, who need unit tests anyway, right? Let's take a look at the output. So as I just mentioned, we have now two folders: release, where all our project which had been compiled in release mode will be put into, and our release parallel version, where our CBC exe now is located. Different to the first video, I'm not going to include CBC into my projects. I will use the cbc.exe directly. So how can I test now if my CBC works correctly? The easiest way is, well, at least the way I do it, I create a batch file. Let's call it test cbc. But and open it with some editor. So usually when I write some small batch files, I change the directory to the folder I want to. For instance, now let's change direction to our folder we are located into. And now we want to call cbc.exe, so call cbc, with some test project we have to define. And the argument we want to use is now threads. So if I want to work with 8 threads, I have to put threads 8 here. But we are still left with finding a project, an optimization problem we want to solve. The easiest way is go to your CoinNoir folder. There is a data sample folder, and there are several projects, several test files you can use. Usually I use the MPS files. Let's take, for instance, the wedding 16 MPS. Copy this into our folder, and let's write it just here. So we want to solve wedding 16.mps with 8 threads, and of course we want to solve it. And let's pause the script after this. This is all we have to do to call CBC with a parallel version and 8 threads. If we do this, we will run into some issue, because CBC exe still don't know where to find our pthreads.dll. You can compile it against the library, but if you want to execute this, I can show it here. The code says I cannot run it because I do not know where pthreads.dll is located. But lucky for us, we know where it is located, because we have compiled it into the folder pthreads win32. Again, go to Windows, Visual Studio 2019, bin, release, and copy the pthreads.dll and put it into the same directory as cbc.exe is located. So now we are ready to test CBC with 8 threads. So my machine is a 4-core machine with hyperthreading, so I have 8 threads available, and there is no need to create extra threads, because this will give you nothing except for some overhead. So let's call a command window and try to execute our script and see if we are working in parallel. To check this, go to your task manager, and let's see if the CPU is now it should be working with now 100%, because here we have 8 cores, or 8 logical cores with 4 physical cores. So let's get ready to rumble and see what will happen. So it looks like something is working. CBC is now trying to solve this problem, and you can see my CPU is now working with 100% capacity, and this 100% capacity is now used by CBC. So it looks like our version is now running in parallel and using all the resources which are available on this computer. So let's put it into fast forward mode and see how long it will take to solve this problem. So as you can see, it took CBC around nearly 6 minutes to solve this issue. And it is interesting to see how the scalability of CBC using the parallel version with pthreads actually is. I repeated the calculation for a different number of threads and computed the scaling factor. The scaling factor is the runtime for one thread divided by runtime for instance, 2 or 4 threads. So if you have a scaling factor of 2 for 2 threads, meaning your program is nearly twice as fast as, or is twice as fast as if you only use 1 thread. And what you want is you want a perfect scaling, meaning if you use 4 threads, you want it to be 3 times faster than if you only use 1 thread. However, in my experience, in most of more complex programs, you cannot expect such a perfectly scaled parallelization, because you have some overheap, you have the more threads you have, the more communication you have, the more blocked threads you have, because one thread might be waiting for the other and stuff like that. So it's not that surprising that you only get a not so optimal scaling factor, but still, if you use 8 threads, you are 5 times faster as if you use only 1 thread. So, summarizing, our parallelization works, our compiled program is working in parallel and is actually doing some speed up here. This is also the end of the video. I hope you enjoyed this video and hope it was helpful for somebody out there, how to compile a parallel version for CBC for Windows using our pthreads version. If you have any question, just write in the comments and I will answer you. Have fun, take care, and see you.